Comet stacking can be a little bit of a challenge. I know in my last video when I showed everybody how to stack their comets using Siril, myself included, I ended up with these smeared star trails in the background of the comet stack. In part due to I only had about an hour's worth of data and I was shooting at about 96-97% of the moon being illuminated. I had a friend that had the same issue. He had those artifacts in the background. I've seen a lot of pictures online, people dealing with the same thing. There's only so much you can actually tame them down without losing detail in the actual comet itself. So it was aggravating me and I wanted to get better results, so I started down this path to try to figure out some way that I can pattern match maybe in Photoshop and have some automated process to clean it up. Ended up that was the wrong path to go down. I couldn't find anything. I'm not a Photoshop guy by any stretch of the imagination. What I did discover though is when I started thinking about how StarNet works and how it removes the stars from the image, that's what I was looking for. I wanted something that could remove the artifacts from the image. Thanks to Siril, they have a Python script on their website that will allow us to take a batch of files and dump them into the script, and it'll remove the stars from each and every one of your frames before we get into the stacking process. So as you can imagine, if I have 60 frames now with nothing but the comet in there, no stars, and stack them, clean background. No trails, no smearing, no artifacts, nothing. So as you probably noticed, I said Python scripts. There are some extra steps you need to do to be able to get through this new workflow, which includes installing Python and a couple of Python modules. Don't let that scare you. I have completely uninstalled everything that I had set up from my computer as far as Python is concerned, so I can record it and show you guys step by step what you can expect as you run through it. It's not hard. It's just installing the Python package and a couple of commands, not a big deal. Other thing I wanted to mention is I did steal some of my video from the first comet stacking and copied and pasted it over into this one because some of those steps still apply. So if you've watched the previous video, a lot of this stuff will look familiar to you, but again, just like last time, I wanted an end-to-end solution without needing to tell everybody to jump back and go watch another video before you start this one. Also, I want to send out a big thanks to my friend Ariel. He actually vetted this process for me. I sent him the video before I released it today, and he went step by step to make sure there was no errors, that the process worked as expected. So he gave us the green light. If you have any questions, his email is down below. Just send him an email and he'll help you out. I'm just joking, I didn't do that. But seriously, if you guys have any questions or suggestions, leave them in the comments and we'll try and work them out for you. So let's get the show on the road. My name is Rich. You're watching Deep Space Astro. Okay, we're going to start with installing all the prereqs. I'll leave all the links to these websites down in the description, so you guys don't need to jot these down as we go along. We're going to start with installing Python. Use version 3.10.10. Do not use the one that is not under stable releases. I had some minor issues with it, as well as don't use the one that's in the Microsoft store. I had different but still minor issues with that one. This one worked for everything that I needed to do. Use the Windows installer, 32-bit, 64-bit, depending on your operating system. I'm Windows 11, so I'm going to go 64-bit. And we're just going to download this, click on it. Before clicking install now, you want to come down and tick add python.exe to path. This will allow you to run the Python executable file no matter which folder you're sitting on in File Explorer. Otherwise, you would have to provide this complete install path to run it or sit in that folder and run it. So once you have that ticked, just click install now, give it permissions. Once it says setup was successful, close. That's it. Python's installed. Next, we're going to install the 2 Python modules that we require for this whole workflow. So come down to your start button. You can right click. On Windows 11, it says terminal. On Windows 10, I believe it says command or command line. Or you can run this within PowerShell, because effectively that's what terminal is now in Windows 11. And the first thing we're going to install is something called Pillow. And it's a simple command, so just pip install Pillow. And I'll leave these commands in the description below as well. And then hit enter. It'll go and download the package, install it, and just that quick, that's done. Next thing we need to install is something called Astro. So again, pip install Astro and hit enter. And that one's complete. Now we're going to come over and install PySiril. So this is a Python package for Siril. So when you get to the website, look for your download section. We're looking for the Python package. Just click on that. download it. And then the easiest thing to do, I'm using Google Chrome, so if you're using a different browser, obviously it's going to behave a little bit differently. But once that file is downloaded, I just click on the little arrow and say show in folder. And we also need to run this from a terminal command, so I just highlight the path up here and type CMD, and that will throw me into a command prompt. Back on the web page, again, I'll leave this on the description as well, but this is the command that we want to run to get that file installed with Python. So I'm just going to highlight it, copy it, come back over and right click to paste and hit enter. Alright, so now Python for Siril has been installed. Next thing we need to get installed, or downloaded rather, is StarNet++, the command line tool. If you've used StarNet before and you're running on Windows, you've downloaded the Windows version, the user interface version, which is this one right here. Just show you guys real quick. So this is what we're probably all mostly familiar with. We need the command line version. So I'm going to click on Windows, download that, and once the download's complete, again, tick the arrow, go to show in folder, and I'm going to right click on that .zip file and say extract all. Files will be extracted to this folder. It's creating one that's the same name for us, so I'm just going to hit extract. And I don't want to leave this in the downloads folder because I like to clean that up every once in a while. So I am going to right click on the extracted folder and say cut, and I'm just going to come over to the root of my C drive and say paste. So now we have the command line version of StarNet++ installed at the root of C. So the next thing we need to do is create the Python script. But before we do that, make sure that you are viewing file extensions on your files. So you can see here with these files, monotest5, .tiff, and then I got .bat. Those are the file extensions. So we need to, by default, Windows doesn't show you those. If you don't see your file extensions, Windows 11 has come up to view and show, and make sure you have file name extensions checked. Okay, next we're going to go over to Siril's website, and when you get to this page, scroll down till you see the Python code, and with your left mouse button, just click and hold it down and start dragging, pulling all the way down to highlight everything in this code. The last line here that you want to stop at is run. Once you have everything highlighted, just right click and say copy. Then we're going to come over here to our StarNet directory that we created earlier that we downloaded. And we're going to right click, say new, text document. And we're going to delete everything including the .txt. And the name of our script is going to be auto starnet fits.py. Say yes when it prompts you about changing your file extension. That's fine. Here's our new Python file, but we need to add the code into it now. So right click. On Windows 11, you have to click show more options. I believe with Windows 10, you will automatically see an edit menu pop up, which looks just like this one. So you're going to look for edit with idle and then edit with idle. Click on that. And then anywhere in this box, just right click and paste. We have to make 2 changes to the code in here because I had issues with it. I've reached out to Siril to see what they have to say about it, but I've yet to hear back. But it did throw an error at the end of the processing of each of the files when I used it. So it was looking for the .fits extension and not the .fit extension. So we just need to change that. You'll see the first one right here. Just look for your pound symbols or hashtags for the younger generation. So we're just going to change fits to fit in that spot. And then if you roll up and look for the double row of hashtags, again, right here where it says fits, we just want to delete the S so it reads fit. And then just come up to File and Save and Close. Okay, now we've got all of our prereqs installed and configured. We have our Python script in place. We're going to jump over into Siril and start the whole workflow. Running version 1.0.6 is Siril. Before we get started, just want to show you where I have all my lights and calibration frames. Right off my C drive, folder called Astrophotography, and then one called Comet. I have my biases, darks, flats, and lights. As I've mentioned in previous videos, you need to have these 4 folder structures named this way for the script to work correctly. So we'll minimize that. We're going to hit our home button and select our Comet folder and click open, and then come up to scripts and OSC preprocessing. So we'll let this run over here, and once it's done stacking, we'll get started. Okay, our stacking is complete. So we need to change our home directory in Siril. So we'll back up to the blue house button here, and we're going to double click on process and click on open. The next step is we're going to come over here to sequence, and then you want to hit the blue search sequences button. And what we're looking for is pp_light_.seq. Select that, and then we're going to come down and take our view out of linear, put it in auto stretch, and we can jump real quick over on the RGB. This is showing us our first file within the sequence, as you can see in the top right corner here. Again, most things that you do in Siril, you can't do them on the RGB tab. You have to be on one of the color channels, so I'm going to work on green. And the first thing that we're going to do with the files in our sequence is run a background extraction. So image processing, background extraction. We're going to change our interpolation method and the degree order from 4 to 1. These are the 2 settings that Siril recommends. And if you deviate from these 2 at all, you'll get a pop-up message warning you that you don't need to be that aggressive with your settings, and that this is what they recommend to run a background extraction with. So samples per line, I've got at 20. Grid tolerance, I'm going to bump that up to 4. And we're going to click generate. Make sure we got good coverage of samples all the way around. And I am just going to right click on these samples around the comet just to remove them, so it doesn't interfere with any of the coma or anything else around the comet itself. I don't want that to be determined to be the background. Once that's done, we can hit compute background. And before we apply it, we're going to tick this box down here that says apply to sequence. Prefix, you can leave it the default BKG_. This is simply going to be all of the files with the background extraction applied. New ones will be created with that prefix, and we'll see that here in a few minutes. So go ahead and click apply, and you can watch down on the bottom here as it's going through and doing a background extraction on every image within our PP Light sequence. Okay, so background extraction is completed. Up in your sequence name here, you see it changed from the PP Light to the BKG PP Light. So it selected the new sequence that it just created where it applied all the background extractions to the files. So ensure that you're on the correct sequence. If you're not, you can just click the pull down menu and select the BKG file. Now we need to set a reference frame. So we're going to come over and click on open frame list. The default reference frame is number 1. Reference image is checked up here. The reference frame is basically just how you want the comet framed when we're at the final process for it. I have 60 frames here, so I am just going to pick one in the middle, which would be 30, and then come up here and tick reference image. And then we can close the frame list box. Now we're going to do a photometric calibration. When I do the color calibrations, I like to sit on the RGB tab so I can see more of a visual of the change as it occurs. We're going to apply background calibration to our reference image that we have open right here. The thing is we're viewing this file through our sequence right now. So if I was to come up and say image processing, color calibration, you can see both of these options are grayed out. And that's why. It's because we're viewing this within the sequence. So we actually need to open file number 30. So we're going to go to open, make sure we're in our process directory. And like I said before, there's a ton of files in here, so make sure you select the right one. You can always use the file name up here in the top right corner as your reference. So we're looking for BKG, PP, Light, and 30. That's it right there. So we'll go ahead and open that. Now when we come over to image processing, color calibration, our 2 options are available to us again. So we're going to do a photometric color calibration. And this, you need your right ascension and declination coordinates, and this depends on what you're shooting with. If you have a dedicated astronomy camera and those coordinates have been stored in that file, then you should simply be able to click Get Metadata from Images, and this will be populated for you. In my case, I shot with my Canon mirrorless, and the same thing would happen with a DSLR. You probably won't have those coordinates in the files, so you're going to have to go find them yourselves. There's numerous ways to do this. I usually use Stellarium, but there's some configuration you need to do with Stellarium in order to be able to locate the comet. And I know not everybody uses Stellarium, so I'm going to show you guys a way that everybody can use without needing to install software or configure software. And that is an online planetarium called theskylive.com. So I'll leave the link down in the description. Once you're up on this page, just where it says locate object, we're going to put in the comet. So C0 or C2022 E3 ZTF. There's the comet we're after now. And it shows it to us in the sky, but this is today at the time of the recording where the comet currently is at. We need to get the RA and deck coordinates from the night in time when I shot my images. So the way I do that is come back into my lights folder and just look at the timestamps that are on each of the files. So you can see here, we'll just go with the first one. You don't have to, over an hour, the sky didn't move that much. So we're gonna go with February 3rd at 10 o'clock. So back over to thesky.com and click your little clock icon here, and then change your date and time. So February 3rd at 10 o'clock p.m. All right, so now our date and time matches the timestamp on our light file. And what we're after here is the second line here where it says right ascension and declination. So the first one we need is right ascension, which is 5 hours and 30 minutes. So back into Siril, 5 hours and 30 minutes. And now we need to get the declination, which is 58 degrees and 18 minutes. Make sure your focal distance and your pixel size is correct or close enough. Mine, these numbers will work, but to be exact, 250. My focal length, 'cause I shot this with the Red Cat, and my pixel size is 3.72. Rest of the stuff you could just leave at the defaults and click OK. A console window will come back up as it's doing the calibration for you, and on the bottom here it says that it's been applied. Click close, and very important step when this is complete, and I say very important because the numerous times that I ran through this process, this was the step that I kept forgetting to do, but you want to make sure you come over here in the top right and click your save button. So it'll save that color calibration to our reference image that we have open. If you don't do that, then things are going to start going sideways with the next steps that we go through. Because again, this is our reference image, right? This is what it'll be looking at for everything else. Okay, now we're going back over to our sequence tab, and you can see our sequence. There's nothing in our sequence field, and that's because we opened this number 30 file directly, so it cleared the sequence. So just click anywhere in this pull down, and we want to reselect our background PP light sequence. Once that opens, verify in the top right corner that our reference image is still open. Now we're going to switch our viewing mode from auto stretch back to linear. Come over and open up our histogram toolbox. Hit the cog wheel to apply an auto stretch, and zoom in a little bit with our plus buttons and just play with our shadows and midtones until the image looks the way that we like it. Not too dark on the background. And yeah, I think that looks good, so I'm going to check apply to sequence. My output prefix will be MTF_, and click apply. Okay, the stretching has been completed, and it ran against every file in our MTF sequence. As you can see, the new sequence has been selected for us automatically up here. Our next step is to go over into registration and make sure you're on Comet and Asteroid registration. Back over to sequence. Open frame list, select the first image in your session, close the box, make sure you're on one of your color channels, and then just draw a box around the comet, just like that. Back over the registration, click on Pick Object to number 1. Now we're going to go back to the Sequence tab, back to the Open Frame list, and we're going to scroll down and select the last image in our session. For me, it was image number 60. Close the box and put my mouse right in the middle of my selection. Hold the left mouse button down and move it back over to the comet. Back over the registration, and now we're going to click on Pick Object in number 2. Once you have those 2 steps complete, you can click the Go Register button. Okay, registration has been complete. If we come back over here to our sequence, just make sure that you still have the MTF sequence selected. Now, what we're going to be doing is exporting out all of the files within the sequence. Our base name, I'm going to set to EX underscore. You can use whatever you want. I'm just staying with the naming conventions that Siril's been using. So EX underscore. Make sure Fits Images is selected. And the one thing I want to point out is our selection that we have around the comet. You should just click in a blank area someplace on the screen so it clears that box out for us. I'm going to leave it on just so you see what happens if you forget. It's not a big deal. If you don't expect this warning to pop up, it can throw you for a curve. So I'm going to leave the comet selected like that, and we're going to hit Export Sequence. And this is the warning that I was talking about. It sees that we have a crop selection drawn out over here, so it's asking us, do you want to crop this? We don't. So if you forgot to click on the screen to clear that and you see this box, simply just click Cancel, and it'll still export all of our files out, as you can see down here on the bottom. We'll give that a minute to finish and continue on. Okay, the export is completed. You want to leave Siril open, don't close it. We're going to jump out and do some work with the Python script now. So over the File Explorer, we're going to go and open up our process directory on one side, and we're going to open up our StarNet command line folder that we created earlier in the beginning of the video. What you want to do, the process directory, as you can see, has tons and tons of files in here. So we exported everything out with the files EX underscore. So if we just search for EX underscore, here's all the files that export sequence created for us. So all 60 of them in my case. So I'm just Control A to select them all. Hold the left mouse button down, and I'm going to drag it over and drop it right on top of our Python script to the point where I see it says Open with Auto StarNet Fits.py. Let the mouse button go. Our command window will open up, and it'll start processing all 60 files. It's going to create a starless version and a star mask version for each of these 60 files. If you've used StarNet in the past, you know how long it can take to finish just a single file. I'm doing 60. Last time I ran this through on my system, it took about an hour and a half. So I'm going to pause the video at this point, and when it finishes, we'll come back and finish through the rest of our process. Okay, our Python script has finished creating our starless and star mask files for us. Just so you guys are aware, that command window that popped up when we dragged and dropped over to the Python script just automatically closes when it's done. It doesn't tell you that it's complete or anything. So if you walk away and you come back and that window is closed, it simply means it completed. If there were any errors, that's the only time that window stays open. So you can see here as an example, file number 3, one of the 60 that we dragged over into the Python script. And when it was finished with it, it created an underscore S and an underscore stars. The underscore S is our starless version of the comet, and our stars is our stars mask. So what we're going to do now is go back over into Siril, and then on the conversion tab, we're going to bring back up our process directory, and we need to create a sequence with all of our starless images. So again, we're going to use the search box to do that, and this time we're just going to search for underscore s.fit. That'll give us all of our starless images. Again, Control A, left mouse button press and keep it held down, and just drag it over into the conversion window in Siril. Let it go. So there's all 60 of our underscore S files. We need to give it a sequence name. I'm just going to call this one Comet. You can do whatever you like. Just ensure the default fits image is selected over here on the right, and then click convert. Once it's ready, we don't need to go up into the registration and do the Comet registration because we've already done that. And you can actually see here, here's one of our images with no stars, no artifacts, anything. So we're simply just going to come over to stacking. We'll leave all of the defaults, the Windsorized Sigma clipping and 3 and 3 for the Sigma low and high. There's really not too much rejection that needs to be going on in here, but it doesn't hurt to leave it on. And as you see right here, it says save in Comet_stacked. So that'll be our Comet stack file name. Just go ahead and click start stacking. Okay, our stacking is complete and it is showing us the stack right here. Like I said before, just the comet. No stars, no artifacts from the stars, no smears, nothing that you need to worry about in post-processing. So the comet stack is complete. Now we're going to work on creating a star stack using the star masks that the Python script created for us. So that eliminates a step as well, because in the previous video when we were stacking the comet, we had an image with the stars and the comet that was smeared across the middle. We had to take those two images into Photoshop and subtract them out using layers to get a pure stars image. We don't need to do that with this process. So same way we did it with the comet, we're going to go back over the conversion, hit your little remove all files from list button right here. That'll clear all the _s files. And then we want to come back into our process directory. I'm just going to hit the back button to clear out my search. And this time I'm going to search for _stars.fit. And there's all 60 of my stars only files. Control A, left mouse button down, drag it over, drop it. We're going to change it from comet to stars, and then convert. Come over to registration. We're going to do a global star alignment and go register. Okay, registration is complete. So now we're going to jump over to the stacking tab. Same settings as last time. Windsorized Sigma clipping, 3 and 3 for Sigma low and high. And I'm going to delete the R_ here for the file name just so it's called stars stacked. And then click start stacking. Okay, the star stack is complete, and just like I said, there is no artifacts from the comet in this one at all. So with this one open, we're ready to take the star stack and the comet stack over to Photoshop and get them blended together. So starting with the stars stack.fit, we'll just right click, save RGB image to TIFF, change it to 16-bit, and I'm just going to call this one stars and save. And then come back over here to open, and we're going to open up the comet stack that we did previously. Right here, comet stack.fit. We'll open that one back up, and same thing, right click, save RGB image to TIFF, 16-bit, and we'll call that one comet. Now we'll jump back over to our process directory, which is where we just saved those two. And find our comet, double click it so it opens up in Photoshop, and we're going to come in here and find our stars TIFF right here on the top, double click that to get that one opened up in the Photoshop. And just like we did before with the blending, we'll start on the stars, Control A to select everything, Control C to copy everything, and then we'll come over to the comet, Control V to paste. And again, I'm going to rename the layer 1 to stars just by double clicking on it. We'll unlock the background layer and rename layer 0 to comet just so we know which layers we're working on. Click on the star layer, change the layer mode to linear dodge add, and there's our blend. Now obviously we're going to work on this a little bit more, so I am going to turn off my stars, click on my comet, and just make some adjustments. And I'll just do this real quick. Everybody has their own methods to doing this, so I'll just do a real quick levels and curves on this. We'll just move the shadows over to the edge a little bit, click OK. Come back over to image adjustments and curves. And same thing here, just a little bit on the shadows. bring that up a little bit, maybe do it another time. Our famous little S curve here. Alright, for the tutorial, that's good. So now, again, just come back on, just come back and turn my stars back on. And, you know, if we zoom in here, look at that background. Nice and clean. Again, I know my comet data isn't the greatest. I was shooting during like a 96% illuminated moon that night, so don't have a lot of detail in it. But the purpose of this tutorial was to show you how to remove all the stars from your comet images before you stack them, leaving you with 0 artifacts in the background. And you know, this process really did a great job of doing that. So again, at this point I could just save this off as a JPEG or another TIFF after I flatten my image down, however you guys want to handle it. But there you go. That's the process. That's the workflow that I've been working on this past week. All right, so there you go. Another workflow for stacking your comet. You know, if you follow the first video and you didn't have any of these artifacts, then this is probably not very useful for you. But if you struggled like I did and some other people too with getting that background nice and clean, this should work out well for you. Let me know what you guys think. Drop a comment, like the video, subscribe if you haven't subscribed, and we'll see you next time. Clear skies.